My name is Holly Farrell, and this is my grade 12 Advanced Functions CCT. The learning goal for this instructional video is to be able to use rates of change to solve a problem that involves a function. The key idea to this concept is that the instantaneous rate of change is zero at both a maximum and a minimum point. As a result, the tangent lines drawn at these points will be horizontal. Before moving forward in this video, you must know how to differentiate a minimum point from a maximum. A minimum occurs when the instantaneous rate of change is negative before the value where the rate of change is zero and positive after. Graphically, the tangent lines must have a negative slope before the minimum point and a positive slope after. If the instantaneous rate of change is positive before the value where the rate of change is zero and negative after, then a maximum point occurs. Graphically, the tangent lines must have a positive slope before the maximum point and a negative slope after. In this video, I will be solving question 11F on page 117 in the Nelson Advanced Functions textbook. The question states that a maximum or a minimum is given for each of the following functions. Select a strategy and verify whether the point given is a maximum or a minimum. F. Mx equals 1 over 20 x cubed plus 2x squared minus 15x. Negative 3 and 9 over 5 being either a maximum or a minimum. Since the question tells you that the point given is either a maximum or a minimum, it is safe to say that the instantaneous rate of change is 0 at the point negative 3 and 9 over 5. Like I said earlier, whether the point is a maximum or a minimum, the slope of the tangent line at negative 3 and 9 over 5 has to be 0. Begin this question by factoring out the x. By doing this, you will end up with a quadratic function. Mx equals 120x, x squared plus 2x minus 15. Put the function in factored form to find the zeros. They will be used later on. Mx equals 120x, x plus 5, and x minus 3. To determine whether the point is a maximum or a minimum, the shotgun method can be used. This method consists of picking numbers on either side of the point. This allows you to see what is happening to the function at that specific location. From here, we take our 2 points, negative 4 and negative 2, and plug them into the equation. Correction, negative 0.2. Correction, negative 0.1. As you can see, negative 4 gives you 1.4 and negative 2 gives you 1.5. At this stage, it is already becoming visible that the given point, negative 3 and 9 over 5, is a maximum. To further explain why the point is a maximum, we can use the slope formula to calculate the instantaneous rate of change of the points to either side of negative 3 and 9 over 5. These are the coordinates that will be used in the slope calculations. Coordinates 1 and 2 are used to calculate the slope of the first tangent line. Coordinates 2 and 3 are used to calculate the slope of the second tangent line. Here, I am using the coordinates to the left and plugging them into the slope formula y2 minus y1 over x2 minus x1. The same slope formula is used here to calculate the slope of the second tangent line. It is now very clear that a maximum occurs at the point -3 and 9/5. This is because the instantaneous rate of change is positive before -3 and 9/5 and negative after. Graphically, it is also visible that the point is a maximum because the tangent line has a positive slope before -3 and 9/5 and a negative slope after. Now, you try.